Hello and welcome to the first lecture. In this lecture, we are going to discuss some questions which focus on the data types in C. The first question is about three sizes of each of them have a different value. The first one is 6.5, the second one is 90,000, and the third one is this big number. And we have all the data types in the GNU C compiler. So let's start with 6.5. 6.5, is it a float or a double? Okay, let's see this simple rule. It says that if there is a floating point number which doesn't have any suffixes here, so this is considered a double. Okay, this is the default of double. The default is double. And if it has something like F, L, then this will be float or double, and we will go to this later. So 6.5 is a double. The second number is 90,000 and the number after it. So we need to calculate the limit of integer. How to calculate the limit? We put 2 to the power 4 times 8. And this is the number of bits. Okay, 4 is number of bytes, 8 number of bits in 1 byte minus 1. Okay, and this equals to 2 to the power 31. And after that, don't forget this one, because this will make a difference between the long and the integer. Just one, okay? Just plus or minus one will make a difference between integer and long. So let's see this example. We have here this number, okay, and this number, okay. This exceeds the limit of integer by one, and this is the limit of integer. Let's compile it and see what will happen. Look, here he says that the one with 8 has size 8, which means it's long, and one with 7 has size of 4, which means integer. So let's go back to the show. So here it's this is double, and the second one is integer, and the third one is long. Okay, so let's see this rule. Yes, it's saying it's talking about the suffixes. Okay, and this brings us to discuss the meaning of a constant suffix. You may have seen something like this. Okay, it's very popular in embedded system especially, and it's something like a macro, and it's defined by a value, and then there is a ul at the end, and this is called an integer or constant suffix. Okay, if we examine this table, you are seeing a group of suffixes which when added to the end of any number, it forces the compiler to consider this number as a special type. You can see here when f is added, it's a float, and you can see here ll, it's long, and the unsigned integer, okay, is u. Okay, let's apply for what we have just seen by this example. We have 6.5, 6.5, f, 62l. First one, of course, is double. Okay, the second one is a float, and the third one is long. So the size of double is 8, 4, and long will be 8. Okay, don't forget that L is a long double, but just long to be long integer. Yes, because it depends on what. Yes, yes. Look here. Don't forget this. L has just can be just long integer and can be a long double number. When it depends on whether the value has a floating point or not. Here it has floating point, so it's a long double, and here it doesn't have floating point, so it's just long integer, of course. In the third question, we have two format specifiers. that of f and that of d. This is for float, and this for integer, and this for float. And we have a simple arithmetic operation. Okay, when we have 10 divided 2, this is an integer. Okay, divided integer, this will give us an integer. So what will happen when we try to display an integer by a float specifier? This gives us 0. Okay, don't forget this. The second one is 10 divided 2. Okay, and the format specifier is d, so 5 will appear. The third and last one is 10 has suffix f and 2 has suffix f, so it's a float divided float, and this will give us a float 5.0000. So the correct answer is number B. The next question is about has a new trick, which is the first one. What is this? Okay, we all know that this is character A, of course, but is this treated like a character, like a char, or it's treated like something else? We will know. The second one is a const char and char. They are always one. Okay, almost all the compilers now they're almost one, and if the question is dealing with a different compiler, it will tell you that the char is not one, but it's always one. Okay, so let's see here. What's actually is the single quotation A? The single quotation A is not a char. Okay, it's something called character constant. And by the way, character constant is not a constant char. It's something like A, B, anything between two quotations. Okay, the C standard ISO 9899 calls this a character constant, and it gives a note on this and says that an integer character constant has a type of int. Okay, so the size of int is 4. So in the last question, this has the size of 4. So it's 411. But let's continue reading about the last note, which says that the value of integer character constant containing a single character that maps to a single byte execution character. Okay, so it's just, yes, it's an integer, but you can actually assign it normally to any char. Okay, it maps, and just the standard C consider this an integer, but it can be mapped naturally without any warnings, without any errors to any character, as we always use this. Okay, the next one is an integer main, int main, and there is 3 size of. The first one is 7/2. Second one is with this shape, and the third one is with this shape. And he doesn't ask us about what will be the output, but he asks about the integral constant, the types of integral constant enclosed here. Okay, so the first one is double. Okay, why it's double or not double? No, it's not double. Why? Because 7 is an integer and 2 is an integer. Okay, and when two integer is divided by each other, this will result an integer. The second one is 7.0, just being a present of a floating point. This makes the number a double. Okay, so double divided by double will give us double. The third one is 3.5. It's always double because there is just a floating point. So it's integer because so it's an int double double. Okay. The sixth question is about yes, how size of works. Okay. We have here not logical not, and after this there's a num, which is a double. Okay, and we have here a var, which is an integer, and we have here another var, which is an integer. Okay, so the first one is a big trick, and let's break it down. Okay, when we have not num, this is logical. Okay, if there is inside something other than 0, it's treated like a logical 1. So the not of a logical 1 is a logical 0. So here is just the size of 0, and the size of 0 is an integer. Okay, so this will be printed for the size of integer. The second one is var equals 15/2. Whatever there is here, I'm just concerned with this. Okay, this var is an integer, so immediately the size of this expression is the integer 4. The third one is var, which is integer, so it's 4. So it's this is wrong. oh, sorry, I'm sorry. This is just not size, okay? Take care because this is tricky. The third one is just printing the variable, not the size of it. The last question, maybe, yes. It's signed I equals 10, static I equals 10, and signed I constant I. You may notice that there is no any types. There is no ints, there is no characters, there is no double, there is no anything. And it examines you if you know if this is this right or not right. Okay, so the default data type are always integer. So all of this are valid. They are all of them are correct. And by the way, if you seen this, the unsigned I equals 10.5. Okay, this is an integer. Okay, but this is not an integer. This is double. Is this valid? Yes, it's valid, but it's not a good practice in programming, and this will give you a warning in the compiler and tells you there's an implicit conversion from double integer, but it will pass and it will work. Okay, so the answer is that all are correct declaration. Okay, now we have finished our first lecture. Let's go to the second lecture. Thank you.